Yeah, Jacob. Hello, Jacob.
Yes, sir.
Yeah.
Yes, sir. It's activity 1.9, the sixth question.
Yes. What is?
Um, so this is about the whether the function is bijective. They've given a linear function
Hmm.
ax plus b,
Hmm.
and then they've given some options that uh, when we vary the values of a and b, what do we get? Is the function bijective or not?
Correct. Yeah.
Yeah. I didn't understand how do you approach this problem?
Okay. So the thing is, okay. So there is no fixed values of A and B, right? So A can vary over bunch of numbers, right? So what is your question? So you have a function from Z to Z, okay, and the function is defined as f of x equal to ax plus b, right?
Ax plus b, yes, sir.
Yeah. So the thing is, so A and B, they vary uh, over some sets, right? So for
Yes,
different
sir.
option, you have different possible choices for A and B, right?
Yes, sir.
So now you need to check one by one option, like for what values of let me maybe let me do it for option one. So can you tell me what is option one? Let me check. So option one is a equal to 0 and b is basically over. So a equal to 0 and b is is basically set up all z, and z are in integers.
Yes, sir. This one I understood, sir. This would be a parallel line, and I understood this one.
Yeah.
Parallel. Yeah.
Okay. So let me just okay. I'll try to let me go through it. Okay, for the sake of maybe completeness.
Okay.
I'll try to even I'll try to go. I'll try to cover few more options. Okay. So as you can see, so if I take a equal to 0, then my function f of x becomes b, right? And b actually varies over all the integers, right? So for instance, if I take b to be 1, let's say my b to be 1, okay, so then my function f of x becomes f of x equal to 1, right?
One. Yes, sir.
So that means this is a constant function, right?
Yes, sir.
So certainly this can't be bijective. Okay, so option 1 is invalid, right?
Yes, sir.
And similarly, you can try with b equal to 2, b equal to -1, b equal to -2, whatever value you take for b, you will always end up with a constant function, right? Okay.
Yes,
So
sir.
let's take option 2. What is option 2? Option 2 says a equal to -1, 1, and b varies over integer, right? A equal to -1 and 1, and b varies over integer,
That is it. Yes.
right? So maybe let's start with a equal to 1, right? If a equal to 1, my function becomes f of x equal to x plus b, right?
Yes, sir.
So now I have to check that if for all the values of b, okay, for all the values of b, so for different values of b, I will get a different function, right? So for example, if I take b to be 1, right? So if you have any doubt for this question, you can ask me. Okay, you don't have to raise your hand. So if I take b equal to 1, then I will get a function, right? F of 1 equal to x, which is x plus 1, right? This is a different function. This is a new function. If I take b equal to -1, right, then I will get one more function, f of -1 of x, which is x minus 1, right? So I need
Yes,
to,
sir.
so you know that this b varies over all the integers, right? So b can be any integer, right? Or maybe you can take b equal to 2. So in that case, you will get f of 2 of x, which is x plus 2, right? And
Yes, sir.
so it's okay. So it's I guess now you can do it, right? For all these values of b, you can say that this is always a bijective function, right?
Correct. Yes, sir. Yes,
So
sir. So, but the last option, it says a is equal to a takes any integer. If
hmm,
a takes any integer, it can be 1x, 2x, 3x, 4x, like that, right, sir?
correct.
Then that is also bijective, right?
No, that is not bijective. So for instance, let's take a to be 2, right? A to be 2. So what you will get? F of x
Uh,
equal to
2x.
2x plus b, or maybe for simplicity, like b to be 0, right? So
Yes, sir, b is
then
0.
then take f of x equal to 2. So this, so you can see, right, this is an injective function, correct? So
Oh,
that,
yes, a
I
1, 1
guess
function.
you agree, 1 function,
Yes,
injective or
yes,
1 okay, that certainly you agree. But my, so what basically I want to say, this certainly this is injective, but this is not surjective, right? Because so,
okay,
so
okay,
what,
yes, sir.
so you are taking this function is basically from z to z, right?
Okay, yes, I understood. I
So
was
what,
thinking from real numbers to Z.
yeah, so
That was
per so again, like if you consider this function as from r to r instead of z
yes.
to z, then you are correct. Okay,
Okay.
you're absolutely
Yeah,
correct.
yeah. I didn't see that one from that perspective. Okay,
Okay,
I got it. Thank you, sir.
thanks. Oh, okay. Anyone have so anyone has any doubt from this question? So that I don't want to repeat this question again. Okay, if you have any doubt, you ask me now.
Yes, so why it is not onto, sir? It is an injective function.
This is, so you agree this is injective, right? So what will be the pre-image of, let's say, pre-image of 1? Okay, so one request, whoever is not asking question, please mute yourself. Okay.
Sir, actually, I joined right now to sign in.
Sir, please
Uh,
can you tell which question is this? Which activities?
Okay, I have okay, so I was getting a lot of noises.
So I
So
have a doubt.
1.96 question.
1.9, question number 6. Okay.
So
So
can we
you
ask questions from graded assignment too?
see, please listen to me. Okay, so don't. I'm so first try to listen. First listen to me. What I'm saying. Okay, and if you have any doubt from this question, whatever I'm talking now, please ask your doubt. Otherwise, please mute yourself. So okay, so as you can see, this certainly, as already someone said, this map is injective. So, and why this map is not surjective? So, what will be the pre-image of, let's say, 1, right? Pre-image of 1. Whoever asks, like
Yes, sir.
someone asked me, right, why this function is not surjective? So, okay, so let me repeat. Okay, I can't repeat it again and again. So please mute yourself if you are not asking any question. Otherwise, I can remove you from the session. Okay. Uh, okay. So what is the pre-image of 1? Any idea?
It will be 1, sir.
How? If I take 1, then I
1
will
by
get.
2.
Then
Two,
I will.
sir.
Then I will
No,
get
sir.
2, right? So certainly 1 is not a pre-image of 1, right? If you are putting 1, then you are getting 2, right?
Correct.
So
Yes.
Yes, sir.
1 by
and someone said 1 by 2, right? But see, the
Yes,
thing
sir.
is, you can't take 1 by 2, because see, what do you mean by pre-image? So this function is a map from Z to Z, right? This is a map from Z to Z. So when you are saying you have a pre-image, that pre-image
Okay.
should be
It is
inside this Z, right? And when you are saying this is half, then half is not a member of Z, right?
Yes, sir.
So in that case, you don't have any premise for 1, right? That means
Yes.
the function is not on. Clear? And similarly, you can say, you can show that even you can show that it has no premise for 3, 5. So the thing is, what you will get if you multiply an integer with 2, then you will always get an even number, right? You will always get it. Barsa Sharma. Yeah, so this is always a even integer, right? So you don't have pre-image for odd integers. Okay.
So I have a doubt.
Yes, sir, correct. Sir. Okay. Now, because of that only it is not surjective.
Yes.
Because
Sir,
odd numbers are left out.
sir, sorry. Actually, I joined just 4 minutes before. I was stuck in the sign-in process. I just want to know if you can just repeat once this question and doubts are cleared, the same question very fast forward, because I don't want to.
No, so you can,
have
as I said, like you can see the recorded session. No, like
Okay, no
there
problem, no
there
problem.
are so many questions, so I have to cover.
Continue.
So I have a doubt.
Nirbhay.
Yes, sir.
Yeah. Yeah. Tell me what is. Yeah, you have posted activity 1.7 question number 4, right?
Yes, sir.
Yeah. What is your doubt? 1.7 question number 4.
Sir, in this question, I
Hmm.
want to know how to solve for. Matlab, there is a one situation in this
Hmm.
question. This is consider each person suggested only one place. Sir, how to solve this particular statement in this question, sir?
Okay, so let me read the question. So you have a group of people. Okay, 25 people are planning to get together to celebrate their 10 years of friendship, right? Out of
Yes,
them,
sir.
nine suggested to Goa. Okay, 8 suggested to Bangkok, and 8 suggested to go to Pondicherry, and 3 of them did not suggest any place. Okay, so consider each person suggested one place. Okay, what is the value of X, right? So that means only one person, a single person, has suggested only one place. Okay, so for example, I cannot suggest for Goa and as well as for Bangkok. Okay, so that means you are basically getting a linear equation, right? See,
Yes, sir.
so you have 25 people, right? Hello,
Yes, sir.
you have 25 people, right? 10 out of them, 9 suggested Goa, right? 8 suggested what? 8 suggested Bangkok, right?
Yes, sir.
70.
Then next, what you have? 8 suggested
Unknown figure.
8 suggested Pondicherry, right?
Pondicherry.
Yes, sir.
Unknown figure. Pondicherry.
And then you have 3 they basically they didn't suggest anything, right?
Anything.
And you have one more thing, that only one person can suggest at most one place, right? That means 9 plus 8 plus
5.
x plus 3 is 25, right?
Okay, sir.
So now you can get the value of x, right?
Yes, sir.
Clear now? So
Yes, sir.
so they are actually
Clear.
so since it is given that only one person can suggest at most one place, that's why we can easily add all this. That is
Okay,
the main.
sir.
Yeah.
Sir, got
Thank
it.
you, sir.
So I have a doubt in exercise 1 activity question.
Archit,
First in
Yeah, just a minute. Please put your question in the chat box. Okay, I'm following the chat box. Okay, Archit. Archit, are you here? Okay. Pranjali.
Hello, sir.
Yeah.
Sir, I have a doubt in activity question 1.6. Question number 7.
Okay. Activity 1.6.
Question number 7. Sir, I don't understand this question.
Okay. Please mute yourself. Whoever is not asking question. Yeah, so question number 7. You have question number 7, right? Or
Yes.
yeah.
Yes.
So so you have two finite sets A and B, such that the total number of subset of A is 56 more than the total number subset of B, right?
Yes, sir.
So you have two set A, right?
Yes.
And you have another set B, right? And it is given that total number of subsets of A is 56 more than the total number of subsets of B, right? So suppose now you consider, suppose A has m elements, right?
Okay, sir.
A has m elements and B has, let's say, n elements, right? So can you tell me what will be the total number of subset of A?
E.
Sorry?
Sir. Sir, I don't understand the question. Can you please explain?
Sir, it will be m into n.
No, it will be 2 raised to m.
Correct.
2 raised to m.
plus 56.
So
2 raised to m.
So if a set has m elements, my question is, if a set has m elements, then how many subset? Then what will be the total number of subset of A? Okay, that was my
2
question.
ka power m. 2
Correct.
2 raised
Yeah.
m.
Yes.
2 raised to
So-
power m.
So the total number of subset of A is 2 power m. Okay. Okay, please again, like, see, please mute yourself. Okay, so if you keep doing the same thing, then again it will waste your time. So, and B has n elements, right? So similarly, one can show that, so by the same logic, the total number of subset of B is 2 power n. Okay, but in the question it is given that the total number of subset of A is 56 more than the total number of subset of B. That means 2 power m is nothing but 56 plus 2 power n. Clear?
Yes,
Yes.
sir.
Yeah. So next, what you need to do, you need to subtract 2 power n minus 2 power n, which is 56, right? What is 56?
64 minus 8.
64?
Minus 8.
64 minus 8, right? So what is this? You can say this is 2 power
2 to the 6.
6 minus 2 to the power 3, right? Okay, so again, like you can, maybe you can do it. So this probably, so this probably will give you the answer, but okay, this is not the correct way of doing the things. You can do it more formally. Okay, so from here, actually, you can say that m is 6 and n is 3. Okay, is it clear?
So can you just show
Yes,
us
sir,
how
it's
to do
clear.
it more formally as well?
So the thing is what you need to do. Okay, so let me do it. So from here, actually, you can get the answer. Let's say you have 56. So you try to factorize this 56. Okay, what is this 56? Okay, and this you can write 2 to the power n, 2 to the power m minus n minus 1. Okay, what is 56? What is the factorization of 56? How I can write this 56?
8
8
multiplied
into 7.
8 into 7, right?
Yes.
So yeah, so now this I can write it as 2 to the power 3 times 7, right? So from now, from you have this fundamental theorem of arithmetic, right? You can write an integer in product of primes in a unique way. So if you apply that, so from here you can say that 2 to the power n is precisely 2 to the power 3. That means n equal to 3, right? And 2 to the power m minus, so now you know the value of n, right? And again, you can get that 2 to the power m minus n minus 1 is 7, right? So now you have m minus 3 minus 1 is 7. That means 2 to the power m minus 3 is 8. Okay, so which is same as 2 to the power 3. That means m minus 3 is 3 and my m is 6. Clear? Whether this process is clear to all of you?
Yes, sir.
Yeah.
Thank you.
Thanks.
Sir, can you please repeat once again?
Which
Question number 5, sir, same activity.
just a minute. Which part you want me to repeat?
Sir, from n equals to 3.
So this part is clear, right? 2 power n is equals to 2 power 3 implies n equal to 3. This part is clear?
One second. No, sir, just the previous step.
So see, you have a fundamental theorem of arithmetic, right?
Okay.
So what basically it says, you can write a number in product of primes in a unique way, right? That is the statement. So now you have here you have 2 power n, right? So and here you have 2 power 3, and this 2 doesn't divide this part, right? And as well as 2 doesn't divide this part, right? So that means this part and this part, they have to be same, right? So so that means 2 power n is same as 2 power 3, correct?
Correct.
That means n equal to 3.
Yes.
And this part, whatever left, this part should be equals to this part, right?
Yes.
And that is what I have done. If this part is equals to 7, then from here, so now I know the value of n, right? I can substitute it here, right? So once I substitute it here, then what I will get? 2 power m minus 3 minus 1 is 7, right?
Right.
That means 2 power m minus 3 is 7 plus 1, which is 8, right?
Okay. Got it.
Which is 2 power 3, right? Yeah. Okay, Rajesh Prabhu.
Good evening,
Rajesh,
sir.
yeah. Tell me your question, your doubts.
Sir, first is activity 1.8, question number 5.
Activity 1.8, question number 5.
Yes, sir, it's a minor doubt that the accepted answer is shown to be the last one, but I don't think in the question it is given that Anil is the brother of Neha and that Ramu is the brother of Keith.
So the problem is actually, so there is a slight problem. So if you see actually the question, okay, so
Yes, sir.
it's sort of a transitive relation. See, if I am maybe let's say if A is a brother of B, okay, so
Yes, sir.
so you have to check actually if A is a brother of B, okay, and C is a brother of B, okay, then A is also a brother of B. A is also a brother of C, right? So that you need to check. So it's not, so this information is not given directly in the question.
Okay, sir. Got
Yeah,
it.
so
Got
so
it.
you have to check it explicitly.
Yes, sir. So next one is question number 7 of the same 1 point.
Question number 7, right?
Yes, sir.
Yes.
So we have to pick out incorrect statements,
Hmm.
and one of the accepted answers that elements in Cartesian product will only be in pairs is said to be incorrect, which I don't
Yeah.
think is the case.
See the okay. So the problem with the Cartesian. So what actually you okay? So so what actually you do in the Cartesian product? What is first? Tell me what is Cartesian product?
Sir, a Cartesian product is when you take you make ordered pairs of the elements coming from two sets.
See, the concept of the Cartesian product is not restricted.
It can
to,
be 3 sets.
Yeah, it's not
Yeah,
restricted. It's not restricted to 2 sets, right? I can take R.
Yeah,
plus
yeah, got it, sir.
Yeah.
N tuple thing.
Correct.
Yeah.
Correct.
Sir, just next one is 1.11, question number 4. Could you explain it how, like
1.1 question number?
So 1.11, 1.11, question number 4.
Okay, so again, like, see, you have to check this option, you have to check one by one, right? You don't have any other option because see, for this question, you have infinitely many choices. Okay.
Yes, sir.
So, but
So could you check the last one, please?
yes, sure. So you have last one is 67, right?
No, sir. Question number 4, let us define a function from Fs.
So what you are saying, 1.1, right?
So 1.11, 1.11.
Okay, sorry. Yeah.
No problem, sir.
You said it correctly. Yeah. Question number 4, right?
Yes, sir. Last option.
Okay, so last option. Okay, so it's basically you need to check f of n equal to n plus 1 by 2. So so you have a function, right? So your function is f of n,
yes, sir,
equal to n plus 1 by 2 if n is odd, right?
Odd.
And you have n by 2 if n is even, right? This is your function.
Yes, sir.
So first tell me whether this function is on to, so how we have defined this function? What is the domain of this function?
Sir, it is from set of natural numbers to the set of natural numbers.
Yeah, so that means both domain and codomain, they are same, right?
Yes, sir.
So can you, so what about injectivity, whether this function is injective or maybe say 1 1?
Yes, sir, it is 1 for like every value of n.
So there is
at
one
least
input and
This matter.
one.
See, for the one input, you should get one output. That is precisely in the definition of function. Okay, so if it is there in the definition of function, then what is the point of defining 1 1 function? 1 1 function basically says two different things, they cannot go to the same thing, right? You can't have two different thing in the domain.
It is
okay?
not 1 1, sir.
Yes, correct. So you can't have two different thing in the domain so that they can map to the same thing. Okay, that is the definition of 1 1. Okay, so you can't have two different natural number in the domain such that they map to the same natural number. Okay, so for example, first tell me what is the image of 0? What is f of 0?
Sir,
what is
0 would be
1
0
by
only,
2. 1 by 2, sir.
Sir,
Sir, 0.
it is not either
1 by
odd or
2.
even.
0.
So 0 is even. Okay. So that's why 0 by 0, 0 by 2 is 0. By definition, if n is even, then 0 by then f of n is n by 2. Okay,
Yes,
so
sir.
f of 0 is 0. Okay. And what about f of 1?
Sir, f of 1 would be 1.
1 by 2.
Not 1 by 2. Okay, so this you try to substitute n equal to 1. Okay, 1 plus 1 by 2, you will get 1. Right.
Yes,
See,
sir.
so what about f of 2?
1.
1.
Got it, sir.
So this is not 1 now, right? Because
Yes, got it.
you have 1 here in the domain and you have 2 here in the domain. So this is your domain, right?
Right.
And this is your codomain.
Yes.
And the problem is they both of them go to 1, right?
Okay, sir.
So
Got it, sir.
this is not 1. What about on to?
Sir, on to, because sir, every natural number is either odd or even. So we will have a corresponding image for every odd or even natural number.
So I'm not very much convinced with your answer. Like, can you say it maybe more mathematically?
Sir, like for every value of n will either be odd or even. So if we put in the values, if it's odd, then it will the +1 will make it an even number, so it would be equally divided by 2. We will have a natural number to ourselves. So like every input value will have an image. So it will so the entire codomain will become our range. So it will become onto.
So for instance, what actually you need to show? You need to show that for each natural number, right, over
Yes, sir.
here, each natural number in the codomain, you have a pre-image.
Yes, sir.
In the domain, right?
Yes, sir.
So for here, actually, what you need to do, you need to use this. So if you look into this notation from here, actually, you can easily say that this function is onto, right? Because see, if I take, let's say 0, then this will go to 0, right?
Right, sir.
If I take 2, it will go
1.
to 1. If I take 4, it will go to 2, right? So if I have a number here in the codomain, if I have a number here in the codomain, okay, then its pre-image is what? It's twice of that number, right?
Yes, sir.
Twice of that number. So if I take 2k, I'll get k. Okay. So in particular, what I basically showed, for each element in my codomain, okay, I have a pre-image in the domain. So that precisely shows that f is on. Clear?
Yes, sir. Clear.
Yeah.
Sir, just the last doubt is in the question preceding this.
Hmm.
Could you explain why the first option, under root of 3x plus 15, is an accepted answer?
Which one?
So question number 3 of the same activities.
So can you repeat this?
Just a minute. I can't repeat the whole question. Okay, so if you have any,
No, sir. Last.
yeah, I'll come to that. Okay, so question number 3
of 1.11.
Sir, just before that, sir, is this not being recorded because nothing is streaming on YouTube? Just for that. So this session is not being streamed on YouTube. So is it not being recorded, or?
I guess.
I think it will publish after the session.
Yeah, I guess they are recording the session. I'm not very
The recording is going on as far as
Recording is going on.
Okay.
After
It will
the section,
publish
this
after the
is
session.
automatically on YouTube channel.
Yeah. So question number 3 basically is saying which of the following function is always
non-negative.
Non-negative. Okay.
Yes, sir.
Which of the following function is always non-negative? So what is your problem in this question?
Sir, problem is, could you explain how the square root can be like non-negative, because the domain is given as like all real numbers?
No. It's domain is basically all the elements in real numbers, so that f of x equal to r. Okay. So you can't take, see, so what is given in the question? What is given in the question? What is the domain of F?
So the domain of F is X belongs to the set of real numbers such that the Fx also belongs to real numbers.
Such that F of X is in
real numbers.
R, right? That is
Yes,
the
sir.
domain. Okay. And what is your function? F of
Sir,
X equal to
under root of 3x plus 15.
3x plus 15, right?
Yes, sir.
So you are saying that the domain of this function is R. This is not possible because what it's saying. So the domain of the function is consists of all the real numbers, right? Such that the image of this function is inside R, right? So if I take x equal to minus 10, right?
Yes, sir.
If I take x equal to minus 10, okay, then what I will get? F of
Sir.
minus 10 is what? Square root of minus 15.
Function won't be defined.
Okay, so this is not in R, right?
Right, sir.
So that means 10 is not in the domain of this function.
Okay, sir. Yeah.
What is the domain of the function? So you have to take, so by definition, domain is all such x,
Yes,
such
sir.
that F of x is always
Yes, sir.
in
You
some
can
sense. See,
you
this-
can you can only take the values which don't render the function undefined.
Yes. So see, if I'll get a negative number here, then then this function will be undefined, right? So I have to take all such x such that 3x plus 15 is always greater than equal to 0, right?
Right.
That means x has to be greater than equal to minus 5. So the domain of this function is what? Minus 5 closed interval to infinity. Clear?
Understood, sir. Thank you so much, sir.
Yes.
So may I?
No, just a minute. Kumar Sanu.
Yes, sir.
Hmm.
So my doubt is from 1.6, question number 2, activity question 1.6. I just have a small doubt, like where to use and or in that question.
Question number 2.
Yes.
What do you mean? What do you
Like
mean by this?
there are two similar options, like in one there's used and in the other one it used or. So I don't get it, like where to use or where to use and.
So that the literal, like if you take the meaning, basically and means intersection, okay, or means union, okay. So this can be, so for example, x is 3 or x is 5, okay. So that means x can be 3 or sometimes x can be 5.
Correct.
Okay. But see, if I take x is 3 and x is 5, okay,
then
this
both the
statement-
conditions should be true.
no, this can't be true. Okay, so for example, x, so simultaneously x can't be equals to 3 and x can't, so x simultaneously, this is not possible, right? X either x has to be 3 or x has to be 5. So this statement is invalid, whereas this statement has some meaning, right?
All right.
So that is what is saying. That is what this question is saying. So so basically, so for example, if you take let's say option number 2, okay, what it's saying, okay, so you have this R, right, such that R is greater than -2, less than 0. It's greater than equal to -2, less than 0, okay. At the same time, and R is greater than sorry, less than or equal to 8 and greater than equal to 4, right?
Right.
So this is not possible, right? This is an empty set. See, it's saying R is less than 0, right?
Okay.
The value of R is less than 0.
Right.
Okay. And at the same time, it's saying the value of R is greater than 4.
Right.
This is not possible. right? You can't produce a real number which is less than 0, and at the same time this is greater than 4, right? This is not possible, right?
Yes.
So this set is empty. Okay, so for example, if I change this thing, okay, if I change this thing to or, then what basically it's saying?
Either of it should be true.
True.
Yeah.
That means this is precisely what? This is precisely this set minus 2, 0, right?
Right.
Union 4, 8.
Basically we use or for union and for
intersection. Correct.
All right.
Yeah.
Okay, sir.
Yes.
Thank you.
Bipin Pal.
Yeah, hi sir. Good evening. I have the doubt for this question activity 1.4 question 1. So there it's like which of the following sets are same. So it is like when I check the answer 1 and 4 and 2. So my
Sorry,
doubt is
can you repeat your question number 1 point?
Activity 1.4 question 1. So
Okay.
this is like if you can refer the question or should I read?
No, I can see the question. Yeah, question number 1. Yeah. Which of the following sets are same, right?
Yes.
Yes.
So the answer was like I had chosen that the answer was 1 and 4, but then the correct answer was 1, 2, and 4. So how come this 2 is included in this? Because that is having an extra element there.
No,
so
but the thing is, okay, see, when you are writing a set, this extra element, not extra, it has, so basically you are writing the same element twice, right? So if I say whether these two, so my question is whether these two sets are same or not.
Yes.
So that is what.
If you consider the number of elements, like say for example, now you're in this Ankita has been written twice. So actually, if this was written only once, then technically I would have said that all these are same. But now since the number of
that is how you define the properties of set. So in a set, when you are writing a same element twice, then it's not going to count this element as twice. It's going to count it as a single element, right? So in particular, what I'm trying to say, it doesn't matter if I write this set as 2, 2, but again, it's not going to increase the cardinality of the set. So in particular, this set is same as this set. Okay.
Okay, the query was regarding this cardinality. Now, if we say the cardinality of the set which is mentioned in 2, it will be 1, 2, 3, 4, 5, 6. So that way I consider that this is not same. So
no. So as I said, like this set is precisely this one. Okay. So again, it's not going to increase the cardinality as well. Okay. It's not, if I repeat the same thing, it's not going to affect the set in all sense. Okay.
Okay, got it. The next question was regarding activity 1.6 and question number is 5, 6, and 7. So question number 5 was in activity 1.6.
No, I can't solve all the question. 5, 6, 7, it's not possible. 6 I have I guess discussed. No,
Okay,
sorry.
so can you
Sir,
please
5,
tell
5,
me
you
about-
can
so can you tell me about 5 then?
Yeah, I'll do only 5. Okay. I can't solve all the question.
Okay, so should I read the question 5 this time?
No. Okay, please, yeah. So please mute yourself. I'm getting a lot of noises.
Okay.
Sir, is it possible? Can you explain 1.4 second question as well?
Just give me a minute. Let me complete this.
Okay, so fine.
Okay, question number 5. So, so what this question is basically saying, this is your set 2, 3, right? So this is closed interval. So in other words, what I can write this set as X belongs to R such that X is less than or equal to 3 and greater than or equal to 2, right? This is how you can write it in the set theoretic form. Okay, this is your interval. Okay, so you have a bunch of options and you want to say which of the following option are the subset of this given set. Okay. Okay, so the first option is what? 0, 2.3. Okay, sorry, 2.3 is closed interval, union 2.3, sorry, 2.3, 3. Again, I guess I have made a mistake again. This is closed interval and intersection with 0, 2.3, and this is one more like. Okay. So first, can you tell me what is this set? Okay, first you have a bracket here, so first we need to finish this operation. Can you tell me what is this set?
So this should go to 0 to 3. It will include all the not 0. 0
Correct.
to 3.
Correct. So this
0,
I can
2.3 and 3.
0 to 0, since the 0 is there, so you have it's precisely 0, 3, right? And this again I have made a mistake. This is 2.3, and now I can rewrite this as 0, 2.3, right? So what actually I need to find? I need to find all the elements which are common to both the sets, right? So which are the elements which are common to both the sets?
0 to 2.3.
0 to 2.3.
0 to 2.3, and 2.3 has to be open, right? Because 2.3 is here, 2.3 is here, but 2.3 is not inside this set, right? Because I have open bracket here. Okay, so 2.3 is not common to both the sets. Okay, maybe 2.3 is here, but 2.3 is not here. Okay, so that's why I'm putting a open bracket. Okay, so now do you think this is a subset of this set 2, 3? So then this option is incorrect, right? Okay, so again I'll do one more option. Which option you want me to? I'm not going to repeat all the 4 options.
So third one.
Third one, yes.
Yeah.
The fourth option.
No, I'll repeat this third one.
So do 1 minus 1.
Yes, sir. -1.
Comma 4. This is closed interval. You have intersection 0, 3, right? And as the bracket suggests, we need to first find this thing. And can you tell me what is this set? 2 to
4.
Yeah, so 2.5 is here, and I'm basically taking the union, so I can rewrite this as 2,
4.
2
to 4. 4 included.
Intersection 0 to 3. So now you need to tell what are the elements which are common to both the sets.
0 to 3.
Sorry?
4 is a closed interval.
Sorry?
It's a closed
0
interval.
to 3.
Yeah.
2 to 3.
Yes.
So 2 to 3.
Yes. See, 0. See, 0 can't. 0 is not here, right?
Yes,
0 is not here. So 0 can't be. So see, all the elements. Yeah. So basically, if I take a number x, okay, which is greater than or equal to 3, okay. So this is not common to both the sets, because see, if I take an element which satisfies this property, okay, X, then X is an element over here, right? But X is not here, right? And similarly, you can basically say, if I take an element which is, let's say, less than or equal to 2 and greater than equal to 0. See, if I take an element which satisfies this property, then this element maybe is inside this set, but X is not inside this set. Okay, so the precisely all the elements which are common to both the sets is 2 to 3. So now,
Yes, sir.
now, do you think this is a subset of this?
Yes, sir.
Yeah.
Yes,
so
sir.
Then yeah, this is a correct option.
Okay, thank you. Sir, can I ask the additional queries or?
No.
Then I have one additional question not related to the queries. Actually, I'm a working professional, so I'm not
what is
able
your
to
name?
cover. Bipin Pal, sir. You are answering my queries. So
Hmm.
is it like we have to cover this much number of videos and then those all queries will be answered, or all the videos needs to be covered and then we have to attend this session? Because what has happened to me now, some of the questions with the other participants asked, I have not gone through those videos. So I just wanted to know whether that are there certain number of videos which need to go through and then attend these sessions, or is it like all the videos are covered and then all the videos are answered? The queries to all the videos are answered here.
See, the thing is, it's up to you, like how you are comfortable. Like if you want, see, if it is possible for you to cover all the videos, then it's always better to see all the videos and attend the session, so that you can ask most of your doubts. Okay, so it's that is what I can suggest.
Okay, thank you, sir. Got it.
Or Sitha, no, yeah, Sritha.
Yes, sir. Yes, sir.
Yeah.
Sir, I have my doubt in activity question 1.7, question number 1.
Yes.
Yeah, sir. Can you please explain the method, sir? I've been trying to do it, but I'm not basically understanding the question itself. Yes, sir. Can you just explain that on the Venn diagram?
Okay, so
Yes, sir. And also how to approach these kind of questions, these word problems.
Yes, sir.
yeah, so basically there is a standard method of doing this question. Like either you apply the formula, right? So there is a formula, right? What is that formula? Cardinality of A union B union C, right?
Yeah.
What
Is
is the
equal to n of A plus n of B plus n of C minus n of A union B, intersection B, minus n of B intersection C, minus n of A intersection C, plus n of A intersection B plus intersection C.
Yeah. So this is probably the way you
Hello.
yeah.
Sir, can you please explain this on Venn diagram as well?
Yeah. So certainly I am going to explain it using Venn diagrams, but what I'm saying, so you said, right, what are the possible ways of solving this question? Okay, so the first way, either you see whether you can apply this formula, okay, and second, you apply Venn diagram. Okay, so let me draw the Venn diagram. So you have 40 students, right?
Yes.
Okay, so the number of student is 40, and out of which
20 took mathematics.
this is your math, right? And so for example, why actually I have written this formula? So most of the time you can't apply the formula directly. Okay, so for that, first you need to use this Venn diagram to compute certain things so that you can apply this formula directly. Okay, so the cardinality of this set M is 40, right? So M is 40. M is, sorry, not 40, 20. The number of student mathematics course. Then 18 took statistic. Okay. I don't know, maybe they have some intersection. Okay, this is statistic, and S is 18. Okay. So, and one more thing is given, that 16 took English, right? So this is your English, right? Maths, that English. Okay. And 16 to 17 took math and stat, right? So this English is what?
16, sir.
16.
Yeah. So next thing is math intersections, mathematics and statistics 7.
7.
And math and English also 7, right?
Yes.
Yes, sir.
Statistic and English is
9.
9, right? So the thing is, as you can see, okay, so here what basically the question is asking, okay, just
Sir, and also
one more thing is
all-
also given, the common
Yes.
area of this both. This is also given. This is 3. M intersection S intersection
okay.
is given also.
Yeah. M intersection S intersection E is
3,
3,
sir.
right? Yeah.
Yes, sir.
So you need to find how many students are not taking any of these 3 courses, right?
Yes, sir.
So basically what you need to do, you need to find how many. So to get this number, you need to find how many of the students have taken at least 1 courses, right? That is what
Yes.
you need to find. Then once you know that, you just need to subtract to 40, right? Because the total number of students is 40, right? So you know this part, right? This part is, what is this cardinality of this part? This
3,
is
sir.
3.
this part is 3. This part is 3. Okay, so M intersection S, that means this part, right?
Yes, sir.
This is your M intersection S, right? This part is 7.
7.
Okay, so then M intersection E, which is this part. Okay, so this may looks little confusing now. So this part is 7, and you have one more part. Let me use some different color. So this, right? This part is what? What is this part? This part is 9.
9.
Right?
9, sir.
Yeah. So so now what you need to do, you need to compute, okay, how many of these students who have taken only math. Okay, so what basically you need to find? You need to find this region, right? This region. So these are the students who have taken only math. Correct or not?
Yes, sir.
Yeah. So how we can find this thing?
Then it will be 20 minus
7.
3 minus 4 minus 4.
7 minus 3. Sir, first we'll subtract.
See, the thing is, to get this number, you have to find this part, right? Okay. You need to
Yes,
find this part,
4,
right?
4, 3.
And this part,
5.
right? So
Yes, sir.
to get this part, so you know the value of this, maybe this region, right? This is what? 3.
3, sir.
So, and the value of this part is 7, right? If you
Yes.
subtract it from 7, then this part is 4.
4.
Right? And similarly,
Yes.
this part is also
4.
4.
4.
Now the total part is what? 4 plus 4
Plus 3.
plus 3, 8, 11.
11.
11.
Then
9.
Then
20 minus.
20 minus
11.
11. So this part is 9.
9.
So similarly, you can get this part. Or
Yes, sir.
do you want me to compute it?
No, sir. It's
No,
okay.
sir, we can do it.
Similarly, you can get this part, right?
Yes.
sir.
So then
excuse me, sir.
Yeah.
Sir, if we have to find out like students who only study maths and statistics, so it's 4 na?
I guess we are getting a different number, right? 9 we are getting, right?
No, sir, but my question is, if we want to find out the students who only study maths and statistics, so in that case, the answer is 7 minus 3, that is 4, na?
4, correct.
Okay, sir. Okay, sir. Thank you.
Yeah. So this is correct, right? This is 9, right? Am I making?
It's 9.
Yeah. So similarly, you can get this part, right? And similarly,
Yes.
you can get it. So once you know the student who have taken only maths and student who have taken only start, and then you have student who have taken only English, right?
Yes, sir.
Yes, sir.
Then and also you know all these things, right? This part, this part, this part, right? Now you can easily apply this formula. Correct or no?
Yes,
Sir,
sir.
in this
Yes,
in this math, all the things are already given. We have to just determine A union B union C. Then we have to compound. We have to calculate A union B union C complement.
Yeah, that is
the
what.
thing.
So first thing is, see, now you know the cardinality of whatever. Like, let's say
And NA, NB, NC all are given.
M, S, E, right? Then you have this M. So here actually M basically means the number of students who have taken only maths. Okay. This is S and this is E. And similarly, you can replace this A, B, C with the respective symbols. Okay. So now, once you apply this formula, you will get M union S union E. Okay. Which basically says all the students who have taken at least one courses. Okay. And whatever number you will get, you need to subtract.
The number is 34.
Okay, 34. Then you will get 6.
6.
So the process is clear, right?
Yes, sir.
Okay, fine.
No, sir. The universal set is 40, no, sir.
Yeah.
How do you account this M union, S union, E with that 40, sir? In the formula, from the data, we cannot directly apply into this formula. Given data cannot be.
See, the problem is what? See, the problem is you don't know how many students. Okay, how many students they have taken only maths, right? You don't know. The only problem you can't apply because you don't know how many students who have taken only maths, and similarly for other options. So using this Venn diagram, we have computed, right? We have only 9.
9 and 5 and 3, sir. For S it is 5 and for E it is 3.
Yeah. So similarly, you can compute this S and as well as this E, and once you have all the information, okay, then only you can apply this formula. Or maybe you don't have to apply this formula. From here, actually, you can simply add, right? You can simply add.
You can simply add and
whatever number
total.
you have, whatever number you have here and whatever number you have here. Okay, this is a disjoint thing, right? You simply add it. Okay, whatever the final value, 40 minus that final.
But we cannot apply the formula now, sir. How do we apply the formula for the given data and get the solution? Is it possible without using the Venn diagram?
No, without using the Venn diagram, it's not possible. Yeah, that is, see, so what actually I was trying to convince you. Sometimes, okay, you for few questions you can actually apply the formula directly. Okay, but for this particular question, this information is not sufficient. Okay, first you have to find all the things that are required for this
Venn
point.
diagram. We have to put in the Venn diagram and then only we can solve.
Yes, right.
Excuse me, so where do we find these formulas in 11th maths books? Because I know it's not given in the videos.
You can simply find in Google.
It is there in the notes, in the given notes, in supplementary notes.
Yeah, so there is a section, supplementary contents. Okay, so there you can find actually notes for probably week 1 to 3 or maybe 4.
Okay, thank you, sir.
Yeah.
So I have a doubt, please, sir.
Just a minute. I don't know who asked last question. Okay. Aisha.
Yes, sir.
Yeah. What is activity 1.6, question number 5, right?
No, sir.
But you have written activity 1.6, question number 5.
Sir, I have a question. Practical assignment.
Practice assignment. Have you checked the solution of the, okay, whether the solution of practice assignment is available in portal?
No, sir.
No, sir, not yet, sir. It's
No.
not available. For practice assignment, solution has not been updated.
It is there in the course playlist.
Yes, it is in the
Videos there in the
playlist.
playlist.
Okay, practice assignment, question number. Hello.
9.
9.
Yeah.
Hello. 9. Yeah. What is your doubt here? Find the domain and range of the function.
I don't know how to solve this type of question.
It is also my doubt, sir.
Yeah. Okay, fine.
My also, sir.
This is the question, right?
Yes, sir.
Yes, sir.
So the thing is, you need to find the domain and range of this function. So as I said, when nothing is given in the question, you always have to take the domain of A is nothing but X in R such that f of X is also in R. So what is domain? Domain is basically all the numbers in R such that the f of X is also in R. So when this x minus 3, square root of x minus 3 will be inside R.
Okay.
When
root is not, I mean,
So greater than or equal to 0.
greater than or equal to 0.
That means if
X is greater than 3.
Yeah, correct. So if x is less than 0, then square root of x is complex, right? Imaginary.
Yes, sir.
Okay, so if this is less than 0, so I can't consider all the numbers so that x minus 3 is less than 0. So I always have to take all the numbers for which x minus 3 is greater than equal to 0, right? That means x is greater than equal to 3, right? That
Okay,
means
sir.
x is 3 to
Infinity.
So this is the what is this? This is the domain of the function, right?
Domain.
So if this is the domain, that means now
Can you explain in this again, sir? I didn't understand actually.
So this, just a minute. So if, okay, so the thing is, what actually why I don't want to, I have already discussed this type of question once. Okay, so this is more or less similar to the question someone already asked. See, the thing is, what you need to do, you need to consider all the x. Okay, so as I said, the domain is what? All the x inside R, so that f of x is in R. So you need to consider all the x so that the image of that x is inside R. So when this thing is inside R, see, if x minus 3 is negative, then certainly this can't be inside R, because I will get an imaginary number. So this is this square root of x minus 3 is inside R. This is possible only when
X is greater than or
x
equal to
minus
0.
not x x minus 3 is greater than or equal to 0,
Equal to 0.
which is equivalent to this inequality, that is x is greater than or equal to 3. So now this is your domain, and the map is what?
Real x minus 3.
So what will be your range then?
From 0 to
From 0 to infinity, sir.
0 included or excluded?
Included.
0 is included, sir.
Why 0 is included?
Because of close brackets.
Sorry?
Because of the brackets. Because 0 is an acceptable value.
Because see,
Under 0 is 0, sir.
Because the image of 3 is 0. Okay, so 0, that's why 0 is inside the range. Okay,
okay,
so
sir.
that's why 0 is included. Okay, and you can show that, see, if you take, see,
The closed interval will be the one of the
it takes
probability
towards infinity, then x minus 3 also will go towards infinity. So this is the range. Clear?
Okay, sir. Thank you.
Yeah.
So can I ask a question?
No, I'm okay. So I don't have any choice. I'm following this Vikas. Sunita, Abhishek.
Yes, sir. This is my doubt. Now it is clear.
Okay. So Harsh.
Hello.
Abhishek? Yeah.
So my doubt is about the question activity
Can
11.
What is your name?
Sir Harsh.
Yeah.
Sir, the activity assignment 11, question number 6.
See, so the same. So basically, this is now you should able to solve this question. See, I have discussed this question, right?
No, Mama.
Yeah, now you should able to solve this question. Now you try. So do you understand this concept? What all the concept that I have described here? Hello.
Yes, sir, I have understood, but
Yeah,
now
you try to solve.
How to start with that question is something.
Basically, same. Okay. Ditto same. Okay. You just need to add the things. Whatever is given there, you just need to add the things. Okay. Without any change. Okay. The procedure is same.
Okay, sir. And one doubt about the next question about it. So question number 7 and 8. The graph is given of domain and range.
So same doubt with.
Okay, let me explain it. Just give me a minute. Let me take it. Out of this question. Okay, so the graph of a function is given, right?
Yes, sir.
Okay, so zero comma 9. This is 3,1.
Excuse me, sir.
Hmm.
Sir, these questions are already discussed in previous session.
Okay, so great. Okay, so since I have written this question, so let me try to go through it quickly. Okay.
Okay, sir.
Yeah. Again, thanks for pointing it out. Okay, so as you can see, what is this part? What is this thing?
This thing is 0 comma, sorry, 2 minus 2 comma 0 or something. Minus 2 most probably and 0.
How? What is the reason behind your guess?
Because
Sir, minus 4 comma 0.
This is minus 4 comma 0, right? And this is, what is this point?
9
comma 0.
9 comma 0.
So as you can see, you have image for all the numbers in between minus 4 to 9, right? You have image. So if this is my m, then if I draw this vertical line, then I will get some m something. So this is actually the image of m, right? Image of m. So for all the numbers in between minus 4 to 9, I have image, right? So that means this is this minus 4 to 9 is the domain. Now your next task is to find what is the range, right?
Can you explain it again, sir?
So as I said, right, this is, see, all the values in between minus 4 to 9, you have a image, right? Hello.
Yes, sir. Yes, sir.
Yes, sir.
So see, what will be a domain? So you need to consider all the elements which has a image, right? So this is,
Yes, sir.
so this is your domain. So similarly,
Actually, sir, how we determine an image, sir?
you don't have to determine the image. Okay, I don't care what is the image. I just need to know for which elements you have an image. That is what I need to find out the domain, right? So see, if I tell you to determine what is the image, then probably you have to draw a line. Okay, that is a different task. Okay, for this question, you certainly don't have to do that. Okay,
Okay, sir.
And what is the range? Any guess?
3 to 9.
2 to 9.
Sir, 1 to 9.
1 to 9. 1 to 9.
1 to 9. Sorry, 1 to
1 to
9.
9.
My bad. 1 to 9.
So basically, what you need to take all the elements. So if you take, basically you will get this part, right? This part. which is 1 to
9.
9. This is the range of this function. Okay. Okay.
Actually, sir, I'm not getting how it's actually happening.
Sorry?
I'm not getting what actually how you calculated the range. Actually.
So do you agree this is the domain of this function?
No, sir.
Yeah, then okay. So I'll suggest maybe probably you can go back and check the recorded session of tomorrow. Okay. So see, the thing is, okay. Again, like I certainly don't. So see, what do you mean by domain? Okay. So if I have a domain, so if I have a function, okay, from a set to maybe let's say R, right? So
yes,
if I have a domain, right? If I have an element in the domain, then I must have some f of x, right?
Yes, sir.
So for example, if I take maybe say -5 here, okay,
yes,
what is the image of -5? What is the image of -5? If I draw a line, okay, so do you think this line will intersect this graph?
No, sir.
No, sir.
So sir, that means I don't have an image because I'm drawing a graph of that function, right? I'm drawing a graph of this function. That is, this is what? F x comma f of x. Okay. So if I draw this for this -5, if I draw a vertical line, then this line is not going to intersect with this graph. That means I don't have an image for -5. Okay. That means -5 is not inside the domain. Whereas if you take all the numbers in between -4 to 9, okay, and if I draw a vertical line, right? If I draw a vertical line, it will always intersect the graph, right? If I take a number, let's say m, right? I will get what? M comma. So this point is precisely m comma f of m, right?
Yes, sir.
So that means for this m, I have an image that is f of m because it's intersecting with this graph of this function, right? So
Yes, sir.
if I take all the numbers in between, so this intersection is possible if I take all the numbers in between -4 to 9, right? Again, if I take 10, right, and if I draw a vertical line, then again it's not going to intersect the graph, right?
Yes, sir.
So it's clear, right? -4 to 9 is the domain.
Yes, sir.
Yeah. So now you need to find out, see what is the, so now this is your domain, right? So f is -4 to 9. This is your domain. And let's say this is your codomain, right? Now you need to find all the, what is the range, right? That means what basically you are trying to find? You are trying to find this set, right? F of x, where x is in between -4 to 9.
-4 to 9, yes.
That means you are trying to find all the image of all the elements inside this set.
Yes, sir.
Right?
Yes.
So f of -4 is what? F of -4 is what? What is f of -4? See, this is your x coordinate and this is your y coordinate. That means f of minus, that is how we represent the graph. So the problem is probably you don't know how to represent the graph. So f of -4 is 2, right?
Yes, sir.
So that means 2 is in the image of f. And similarly, if you see 6, this is also is in the image of so
F9.
f of 9 is 6. So if I take all the, so I have all this point, right? I have all this point x comma f of x.
Yes, sir.
Right? And what is this f of x? If I project it over here, okay, project this point onto y-axis, then this point is what? This point is 0 comma f of x. Right. So what actually I'm doing? I'm projecting this curve onto this y-axis so that I can get all the y coordinates, all the possible y coordinates of that curve. Okay, that is what I'm doing. I'm projecting the curve completely on y-axis, and if you do it, then the only possible number that you can get is from 1 to
9. Yes, sir.
Yes, now I got it, sir. Thank you.
Yeah. Again, like, see, maybe you try to think it again. Okay, so maybe you can probably try to spend more time, and you can again ask the same question if you want.
Sure, sir. Thank you.
Sir, could you explain the question 10.6?
Just a minute. I don't know where I. What was your name? Whoever asked this question.
Sir, my name is Prashant. Hello.
Sir, I have a question.
Probably I don't know what I left.
Sir, Rahul
Sir,
Yadav.
can I ask question?
Just a minute. I don't know whether. Okay, is there anyone who posted your question in the chat box, but I didn't answer?
Yes.
Yeah. So, what is your name?
Sir, Harsh.
Yeah, Harsh. What is your question?
So practice assignment question 12.
Okay, practice assignment question number 12.
Sir, you are not go through raise hands.
Sorry, no. I'm actually.
I don't know.
Hello, sir.
Yeah, so practice assignment question number 12. Okay, it will take at least 1 hour to solve the question. Okay, I will provide you the solution for question number 12. I don't want to solve this question number 12. Okay, I'll give you the solution. It will take at least half an hour.
Sir, could you explain 1.10 question
It's
number
a very
6?
big answer.
Yeah. And if you, I can suggest, if you want, you can ignore that question as well. Yeah, because I guess I don't know. Because do you have any doubt? Okay, so again, like maybe I'm not. Maybe yeah.
Sir, I want to ask a topic, please.
So no, okay. So the thing is, what actually I was doing, I was going through the chat box whether anyone has any question. So, and
Sir, can I ask a question?
Yeah.
Sir, what are semantic, reflexive, and transitive? How we can differentiate between them?
Have you watched the lectures?
Yeah, I have watched all the videos.
You watch all the videos. First, tell me what is relation?
Relation.
What is relation?
That point. Relation is actually, I can define actually, sir.
Yeah, you tell me now. What is the meaning of relation, or how you define
it? If a set belongs to a real number or not, it's, I think.
Okay, I'll come. Okay, so that requires a lot of time. So I can say that I have to start from the very beginning. Okay, I'll come to that. Okay, maybe if I will have time, then probably I can do all these things. Okay, next question.
Sir, I have a problem, sir.
Sir, can I ask?
Yes.
Can you ask the cardinality of the function?
There is no concept of the cardinality of a function. So there is no concept called cardinality of a function.
Sir, I have a question.
No, someone else was asking.
Yes, sir, I am.
Yeah. What is your question?
Sir, can you tell me what is the mean An equivalence relation partition is that what does it mean? An equivalence relation partition a set. What does it mean?
Okay, so again, like, see, again, my question is, again, I will start with the same question. First, tell me what is equivalence relation?
The equivalence relation is one which is symmetric, reflexive, and transitive.
Okay, so then, okay, what is reflexive relation? You have reflexive.
Yes,
right?
yes, reflexive. A relation is reflexive when xy belongs to R. Give me a second, please.
Then yx belong to R.
No, yx. If xy belongs to R, then
If
for
X belongs to
every R,
x equals to belongs to R.
Every member of set H belong to B itself is reflexive relation. Every member of set.
no. Our relation is reflexive if and only if A comma A belongs to R for like all A belongs to R. I think yes.
Sir,
And
all
it must and it
If A
must
comma
contain.
B is in the set, then B comma A also be in the set.
No, ये जो
This is symmetric.
Symmetric.
Reflexive we are talking about.
Okay.
must contain all the
Okay.
identical
If
elements,
a
and
relation
it can
must
contain other elements.
if a relation contain all the diagonal elements, then it is reflexive.
So from side to
Can
itself.
contain other elements.
Yeah. Okay, so please.
Every element of a set itself to relation. Reflexive.
Reflexive contain.
Yeah, please stop. Yeah, I understand your answer. Okay, no need to give answer. Okay, so suppose, okay, so most of you gave almost all of you gave incorrect answer apart from few. So the main question what basically you ask, okay, equivalence relation. Please mute yourself. Relation. Why this equivalence relation is same as partition, right? Partition of a set, right?
Yes, sir.
So suppose you have a equivalence relation, right? Let's say you have a equivalence relation. Suppose you have a relation, let's say R is a relation on the set A, which is 1, 2, 3, and R is a okay. So first tell me, can you give me a equivalence relation on this set A? Can you define me a relation R which is a equivalence relation on this set A?
Yeah.
1, 1, 2, 1, 2, 2, 3, 3.
1,
1, 2, 1, 3, then 2,
3.
Then 3, 3.
Okay.
1, 2 and 2, 3 must be in the set. Then 1, 3 is in the set. So that is why these are called transitive. And 1, 2 and 2, must be in the set. So this is called
Okay. Okay, please mute yourself. Yeah.
Sir, what is partition of set?
Yeah, I'll come to that. Okay, so first see what is partition of set means. Okay, partition of set is basically, see, see, I can write this set, okay, as 1, 2 union 3, right? And these two are disjoint, right? And their union,
Right, sir.
union is A, right? So this is a partition of this set. Similarly, I can so this partition is not unique. Similarly, I can write 2 union 1, 3. This is also a partition because I can write, and it's not something like you have to write in 2 different sets. You can also write 1 union 2 union 3. Okay, this is also a partition. Okay, so the partition is basically how you can write, it's in some sense how you can write this set, union of few disjoint subsets. That is precisely the partition.
How it is different from subsets? Partition and subset, are they similar or anything?
No, I can write this as, even I can also write this as 1, 2 union 2, 3, right?
Yes.
But this is not a partition because see, these two set have an intersection, right?
Yes.
2 is common, but if you see all these examples, whatever I have written here, so all the sets, they have empty intersection, right? Pick this one and this one, or maybe this one, and you pick any two sets over here, they also have empty intersection. So that is actually the difference between your subset and partition.
Sir, in a reflexive relation, sir, is it must that all the identity pairs have to exist in a reflexive relation?
I'll come to that. Before that, let me say how equivalence relation will give you a partition.
Okay, sir.
So, okay, so for example, so suppose this is a relation. You have taken the simplest relation, okay, which is a equivalence relation. Okay, now what I will do, so I'll try to construct few sets. Okay, so let me construct one set. Let's say A1. And what is A1? A1 is basically all the elements in A such that X is related to 1. Okay, so can you tell me what is this set A1?
Sir, 1.
Sorry?
So it will have only 1.
So this set is nothing, it's only 1, because if you see the relation, then only 1 is related to 1, right? Nothing else is related to 1. Similarly, I can construct this set A2 X in A such that X is related to 2. So what I will get? This will give me
2.
And similarly, A3 is also by the same way. It will only give me 3. So now you can see actually this A1 and A2 and A3, they will give me a partition of A, right? So similarly, you can get some different set if you will take a different equivalence relation. So can one of you tell me a equivalence relation different from the above one?
In the video showing that the clock is a
Sorry,
clock.
What is clock?
One clock. There's a partition into 2 ways, 24 hours, but it's 1 to 12 and 1 to 12.
Yeah, so that is okay. So I'm trying to do it using this equivalence relation.
Okay,
So
okay.
what I'm asking, can you give me
Sir,
equivalence relation?
Yeah,
which is-
a brother
Comma 2,
relation.
2,
A comma
comma
B, A is a brother of B. That kind of relation.
No, that certainly you can't
So
define
1, comma
here.
3 and 3, comma 1.
3, comma 2 and 2, comma 3.
1, 3 and
3, comma 1.
Equivalence 3, 1, 1, 1.
3, 1, right?
Yes, sir.
1, 3. If I take, then I'll get 1, 3. No problem. 3, 1. If I take, I will get 3, 1, which is already there. So okay. So now what I will do? I'll take A1. Right? What is A1? A1 is basically all the elements in my set A, so that X is related to 1. What is this set A1?
1, 3.
Correct. 1, 3. And what is similarly, what is A2? A2 is the same way. X is related to 2. What is this set?
2.
2. And what is this set A3? What is this set A3? X is related
1,
to
3.
3 and 1.
3 1. So as you can see, since X is related to 3, then basically I'll get the same set, right? A1 and A3 are same, right? Because 3 is related to 1. Okay. So if element is here, if A is in A3, that means A is related to 3, right? And I know that 1 is also related to 3 is also related to 1. By transitivity, I can get that A is also related to 1. That means if A is inside A3, that means that basically says
satisfies transitive property.
A is also inside A1, right? So these two sets are same. A1 and A3 are same. So I can ignore one of them. Okay, I can ignore one of them. So if I ignore one of them, again, this will give me a partition of this set. Okay. So that is how so once you have equivalence relation, that is how you construct a partition for that set. Okay, it doesn't matter which set. If you have an equivalence relation on that set, it will always give you a partition. And that this is how you create the partition. So this is a very small example. Okay, again, like this, certainly this concept is not, more or less it's not in your syllabus. Okay, so only some vague definition, I guess, has given. Yeah, any other questions?
Yes, sir. The question about a reflexive relation.
Sir,
So
I have one.
while writing down a reflexive relation, is it must that we have to have all the identity pairs, or we could just go without it? I mean,
no. You must have, so you must have all the identity diagonal elements. Okay, that is the identity pairs. Okay, if you have a reflexive relation, then you must have A, n.
Right, sir.
For all
that.
Yeah, but again, apart from all these elements, you can have few extra elements as well. Okay.
Yeah.
But the relation should contain at least all the elements of this form.
So this is the minimum pair which has to contain.
Yes.
Without it, it can't go.
Yes.
Thank you, sir.
Sir, what is antisymmetric relation?
So what is actually antisymmetric relation says, okay, suppose you have a relation R on A. Antisymmetry relation, basically it's sort of a opposite of the symmetry relation. It basically says if A, B in R and B, in R, that means A has to be equals to B, right? It's saying if A, B is in R and B, A is in R. Okay, if both the pairs are inside the relation, then A has to be equals to B. Okay, so maybe let me take few examples. I have this set 1, 2, 3, 4. Let's take a relation 1, 2,
2,1.
Yeah, 3,3. I will take 2,1. 2,1. Maybe
1,4.
1,4. Yeah. See, now, see, a 1,2 is in R, right?
Yes, sir.
So do you think 2,1 is in R or not?
Yes, sir, we have.
And 2,1 is also in R. So what basically this condition says, if this is in R, this is in R, then A
must be equal to R.
A must be equal to B. So for here 1,2 is in R, 2,1 is in R, but certainly 1
A
is
not equal to
2, right? So that means R is not
symmetric relation.
Not anti-symmetry relation.
Sir, this is a symmetric relation, na?
This is not symmetry relation. How this becomes a symmetry relation? What about this element?
Yeah, 1,4 is there also.
Yes, sir. Sorry.
So this is an example of a it's not anti-symmetry relation, because anti-symmetry relation says if A comma B is in R and B comma A is in R, then A has to be equals to B. So this relation doesn't satisfy. Let me take an example of an anti-symmetry relation, which is actually anti. So let's say 1,1. Okay, maybe say 1,4. 3,1. Okay. So let's take this element. So 1,1 is there.
Yes, sir.
If I flip, so if I consider this as A comma B, if I flip, what I will get?
1,1.
1, so
element of R.
both are inside R, and the good thing about this pair is here
A equal to B.
A equal to B. Okay, so I don't have to work. So I don't have to worry about this pair 1,1. Okay. So the next thing is what? 1,4.
Yes, sir.
Is in R. Okay. What about 4,1?
It is not in R, sir.
So then I don't have to check, right? Then I don't have to check. This is true, because what it condition said, if A comma B in R and B comma, if both the condition holds, if both the condition holds, then only I need to check whether A is equals to B or not, right?
Okay.
So here 1,4 is in R, but 4,1
is not in R.
So I don't have to check this one for this pair. Okay. So this is fine. Okay, this is fine, because I don't have to check the condition. Okay. And similarly, if you take 3,1 is in R. Again, by the same logic, 1,3 is not in R. So I don't have to check the condition. Okay. Again, it says if both the pair A comma B and B comma A, if both
element
the pair,
of R.
if both the pair are inside R, then only I need to check whether A is equals to B. Okay, otherwise I don't have to.
Yes,
okay.
sir.
So that means all the conditions for anti-symmetry relation satisfy for this relation R. So R is an anti-symmetry relation.
So then for the previous relation that you wrote, 1, 2, 3, 4, 3,3 is there. So won't that also be an anti-symmetric relation?
So what basically saying, it should satisfy for all the pairs, right? It should have satisfy for all the pairs. Maybe
okay, got it.
Satisfy for 3,3, but it doesn't satisfy for 1,2, right? So see, if you see what I have done, I have checked for 1,1. Okay, I didn't stop there, right?
Right.
Again, I checked for 1,4 and as well as for 3, I have to check for all the.
Right, got it.
We have to check every element of R, na, sir?
Yes, sir.
Sir, I have a question.
So then identity matrix and identity relation is also an antisymmetric.
Yes, correct. Identity relation is antisymmetric because
activity 1.9 question 6.
Correct.
Then what's the difference between asymmetric and antisymmetric?
Sorry?
So difference between asymmetric and antisymmetric.
What is the definition of asymmetry?
Yes, it means they both are same or different.
No, I don't know what is asymmetry. Can you recall me what is asymmetry relation? What is, if you want to know the difference, can you just recall me? I don't remember what is asymmetry.
If A,
Sir, if A comma B belongs
to
to
R,
R,
then B comma A should not belong to R.
Sorry, if
A comma B belongs to R, then B comma A should not belong to R.
That means, that implies if A comma B, then B comma A should not be in R, right?
Yes, sir.
This is your asymmetry, right?
Yes.
Then suddenly there is a huge difference, right? Because see, now if you see, this symmetry is antisymmetry relation, right? But this is not asymmetry relation. But why it can't be asymmetry relation? Because it's saying if A comma B is in R, then B comma A can't be inside, right? So here 1 comma 1 is inside R, and also this is A comma B, and also B comma A, which is 1 comma 1. This is also inside R, right? So asymmetry is sort of, it's a complete opposite of your identity relation. Okay. Got it?
Yes, sir.
Yeah.
Yes.
Okay. Any other questions?
So activity 1.9 question 6.
Identity. Identity relation is also a symmetric relation.
Sir, activity. Identity relation is a symmetry relation.
So how can it be, sir? How it can be symmetric and antisymmetric also, sir, identity?
No, that is it. No. Okay, just give me a minute. Someone asked me a question, 1.9, question number 6, right?
Yes, sir.
So question number 3 also, 1.9.
I have discussed question number 6, okay, in the very beginning.
Question number 3, sir. Same exercise, activity.
Yeah. Tell me, what is your doubt here in question number 3?
Question number.
So is there a formula so that we can find out if a function is surjective or not, or we have to?
There is no formula.
So we have to check out for values and put values in it.
Yes. Yes. Tell me what is your problem? Which option you are facing? So do you think this is an injective function?
I don't know how to solve this type of problem.
Okay. So, right, this is a map from R to R, right? What is your function? X minus 4 times what? 4x minus 10, right? Are you here or like?
Yes, sir.
Hello? Yeah.
First option, no, sir.
Yeah, so this is your function, right? I have written it correctly. So, what you want to check whether this function is injective or not, right? So when something is given, when a function is given in the form of product of two polynomials, okay. So one thing you should check where this function can give you zeros, okay. So can you tell me for what values of x this f of x is 0?
4, sir.
4. F of 4 is 0, right?
Yes, sir.
Any other value?
Minus
10 by 4.
2.5.
10 by 4.
F of 10 by 4 is also 0, which is, I guess someone said 2.5. Okay, correct. Yeah, 2.5. So now do you think this function is injective?
No.
Yeah, so that is how you do. And surjective is very easy, right? You have a modulus sign.
For negative, we also get positive one, sir.
See, whatever the value of x is, this thing is always greater than equal to 0, right?
Yeah, yes, sir.
So then that means you are actually, you can't get all the negative numbers as your image, right?
Yes.
So that means this function is not surjective. So when you have a function like this, the product of two polynomials, you try to find what are the elements in the domain that map to 0. Clear?
Yes, sir.
Yes, sir.
So activity
Instead of
11.
real
question number
numbers, if we have integers or
So
natural numbers, it is true, sir. It is a surjective, no, sir.
Sorry?
Yes. If the range is in integers or natural numbers, then it is a surjective function. Not even integers, sir. Only natural numbers. If it is to natural
what
numbers,
is the domain?
the domain.
What is the domain?
Real number.
Domain can be real number.
If domain is R, then you can't this cannot be a function from R to N. Okay.
So
See,
activity 11, question number
if
3.
you take
Sir, activity 1.6.
just a minute. Okay, so let me complete this question. So if I take f of maybe say 7/5, okay, I will get some fraction, right?
Okay, sir. Yes.
I will not get a integer, right? So then this function is not well defined. Right? You are writing this as a function from real to n, but you have a real so that f of x is not inside n. Right? So in that case, this function is not well defined. But again, if you write this function from n to n, then probably this is a well defined. Okay. If you put an integer, then of course you will get int. Sorry, if you put a natural number, of course you will get a natural number. Okay. So yeah, so in that case, maybe you can try. Okay, that this if you take from natural number to natural number, most likely it is injective. No, most likely it is injective, but it's not. I don't think it's surjective. Okay. You try to check. Okay.
Yes, sir.
Yeah.
So activity 11, question number 3.
11, question number 3. Yeah, I have discussed this question.
Sir, activity 1.6, question number 7.
1.6, question number 7. Yeah, that also I have already discussed. Thoroughly I have discussed. You can see.
So, practice assignment question number 3. Why is the last option not correct?
Number 3, right?
Yeah.
So I have a doubt in question number 3.
Practice assignment question number 3.
Yes, sir.
Yes.
So
Where is the solution? Practice assignment.
What is the answer of question number 3?
The second and third option. A intersection C is intersection B and D intersection C.
Okay. So what is A? What is A?
All even numbers, all even natural numbers, including 0.
Even natural number, right?
Yeah.
What is
B is
B?
set of all odd natural numbers.
All?
Odd natural numbers.
Odd natural numbers. Okay, then C.
All natural numbers that divide 100.
Okay.
And D is set of all prime numbers less than 100.
Set of all prime numbers?
Less than 100.
Less than 100. Okay. So you are saying why last option is not correct. So in last option, you have C, you have some intersection C with A and as well as C with D.
Yeah.
C with A. C with
That should be an intersection between
C
A and
with
D.
A.
Sir.
Yeah.
That's why it is wrong.
C with D. So do you
C with D is not possible.
C with C? See, A and C has a common number. What is A intersection C?
That is 2.
No, 2. 100 doesn't divide 2. Right? You have only 0.
No. B, sorry,
sorry,
C.
not 0.
Yeah.
You have 0, 100, 200.
There's C.
Okay. 300. This is A intersection C. It will go on. Okay.
Yeah.
What is C intersection D?
So set C will be all natural numbers which divide 100.
All natural, okay. C, you are saying all the natural number which divides 100.
Yes.
Okay, so this, okay. So you
That
are
will
saying
become 2, 5, 10, 20.
2, 5, 10, 15, 20.
Yeah,
Okay,
1, 2, 5,
I have,
20.
yeah. In that case
Yeah.
also you will have a
So that's why I was like C and D will have an intersection of 2.
A and D should be having intersection, but it is not having.
A and
D, there is a common element, but in the Venn diagram,
so you are saying why the last option is incorrect?
Yeah,
right?
yeah. Yes. Oh, okay. I got it. Because 2 is common in all 3 of them, but in the Venn diagram, it's not represented.
Correct.
Okay.
Okay,
Thank
last
you.
option. Last option. Okay, sorry. Okay, A and D. Yeah, A and D have no common intersection point.
Yeah.
Yeah,
Thank you.
so here you have common intersection point. Correct. Basically 2 and 3, I guess. Yeah. No, only 2.
Only 2 and 3, sir. Because
only two.
No, 3 is not even, right?
Yes.
A intersection D is only 2.
Yes, because of
3
element.
is not inside A, right? 3 is not.
oh yeah. I thought you said the third option. Also, sir, this is not a doubt, but in the portal, it said that the last day to submit the assignment 1 was February 5th, but we've been told that it's February 1st. Do you know anything about this?
You are saying graded assignment, right? It's
Yeah.
showing February 5th, right?
Yeah.
Then mostly it's February 5th. Okay, but
Because on the calendar and everything, it was February 1st.
I'm not sure. Like, I have to ask. Maybe
initially it was the February 1st, but it got extended to February 5th from today. So
yeah, maybe. Okay, so see, you can recheck it again tomorrow. Okay, so mostly, but again, like mostly the last date is February 5th.
Okay, thank you.
Okay, any other doubt?
Sir, I have a doubt in question number 3. I mean, this question. I don't understand the conditions of the question. Can you please explain again?
You don't understand the condition. Okay, so what
Yes,
is
sir.
what is A?
A is the all of the
So my first question is, are you able to compute this set ABCD?
No, sir.
Okay, so first thing is what? First thing is A is all. Okay, please mute other. Please mute yourself. Okay. So A is all even natural number, right?
Yes, sir.
What do you mean by even natural number?
Means which divides by 2.
Correct. So that means A is what?
A means
0.
yes, 0, 2, 4,
2,
6.
4, 6, 8, right? So on. Correct?
Yes, sir.
What is B?
B is all odd naturals.
Then what is this at B? 1,
3, 5,
7, and so on.
yes.
And what is C? All the natural number that divides 100, right?
Yes, sir.
So what is C? Can you tell me what is C? What will be the first element of this C?
So maybe 0, 5, 10.
Why 0?
No, sir. 5, 10, 20.
What about 1?
Yes, sir. 1 also. Yes.
1,
2,
2,
5.
Just let her keep the answer. 2 also divide 100, right?
Yes, sir.
Then 3 is not
4.
there, right? 4, yeah. 5, 6 is not there, 7 is not there, 8 is not there,
10.
10, yeah, and so on. You can go up to 100, right? The last member is 100, right? And what about D?
So less than 100 prime numbers.
Yeah, so that means 2, 3, 5, 7, 9, 10, 11, 13, 17, 19, and so on, right? So this is yeah, so you have to do it manually. Okay, and first thing is you don't have to compute all the cells completely. Okay, so you don't have to compute D. Okay. So the only thing is you need to check whether you have some intersection between any of these two sets. Okay, so from there you can actually solve the question.
Okay, sir. Why 0 is not included in set C? Why 0 is not included in set C?
0 doesn't divide 100, right?
It becomes 0 now.
Why?
Denominator can't be 0, na, sir.
Yeah, so that is C. What do you mean by M divides N? That means you can write N as a multiple of M, right? So
Yes.
if you think 0 divides 100, okay, this is your M and this is your M. Then you should be able to write 100 as a multiple of 0, right? Is it possible?
No.
So then 0 doesn't divide 100, right?
Sir, can you please explain how to draw Venn diagram also?
No, Venn diagram, okay. Like, see,
yes.
See, once you know, see, there is nothing to draw here. Okay, so what is A? So see, what is A? This is, maybe say this is your A, right? This is your setting, right? And
yes.
What is B? B is all odd natural number, right? So do you think you have any common element between A and B?
No, sir.
No, right? So then, so B will be something like this, right?
Yes, sir.
Then you come to C. Do you have any common element between C and A?
Yes, sir. Even numbers only.
Do you have any common element between C and B?
Yes, sir. Odd numbers.
Then you must have, when you are drawing this C, then you must have some intersection, right? You have some intersection.
Yes,
C.
sir.
And what about D? Do you have any common intersection of D with A?
No, sir.
No, you have, right? Two, right?
Yes, sir. 2.
D, 2 is in D, right? 2 is also in A, right?
Yes.
So you have a common. So do you have any common element between D and B?
Yes. No, sir.
Why?
Because 2 is not there in B.
No, I'm saying, do you have any common element between D and B?
Common. Yes, sir. Yes, sir.
You have 3 here, you have 3 here, you have 5 here, you have 5 here, you have 7 here. You have a lot of element common. Do you have any common element between D and C?
Yes, sir. 5.
Yes. So D will have common element with all the other sets, right? So then, so you must have intersection with all them. This is it.
Okay, sir.
Excuse me, sir. Sir, could you explain me about injective function? In injective function, why do we have to write function of x1 equals to x2 first, and not x1 equals to x2?
Sorry?
In injective function, why do we have to write function of x1 equals to x2, function of x2 first, not x1 equals to x2? Can't we write first, sir, x1 equals to x2?
No, you can't write. See, while checking the injectivity of a function, okay, so if you write x1 equal to x2, right?
Yes.
Then why you need to check injectivity? See, if x1 is equals to x2, okay, then both the elements are same, right? That means f of x1 is also equals to f of x2, right? That is by the definition of function. What function basically says? Function says image of a single element. So a single element cannot go to two different elements, right?
Okay, sir.
So that means a single element has only a single image. So you are taking a single element, right? This is a single element because x1 is equals to x2. That is precisely x, right? They are same. So then image will be also same. So you are not checking the injectivity here. You are just checking if two elements are same, then the image are also same. That is true for all the functions. Then why you have to check? Okay, you don't have to check it. You don't have to check it because this is true for all the functions. That is, this comes from the definition of the function. Okay, but to check the injectivity, you need to check if the image are same, that then x1 is equals to x2. That is what you check for injectivity. Okay, so
okay, sir. Thank you, sir. I understood.
Sir, what is equivalence class?
That basically whatever we have discussed here, right? Here, if you go, so these are actually, so whatever we have constructed, this A1, this A2, this A3, these are the equivalence classes. Okay.
All equivalent relations are equivalence classes, right?
Sorry?
All equivalent relation are equivalence classes.
No, equivalence class are different thing. Okay, equivalence class is basically you construct equivalence class using a equivalence relation. Okay, relation and equivalence class, they are related, but certainly they are different.
Okay.
Okay, any other doubt?
Sir, I have a question.
Can I know your name?
Yeah, I am Pradeep here. It's a general understanding on forming the relation. Okay, so suppose say if I take a set where it contains say some names. Say for example, if I take some cricketers, say Kohli, Dhoni, and say Hayden, Murli, like that. So some from different people. Okay. So if I have to form a relation where, if we say that a relation where players are from the same country or something like that. Okay. So in that relation, should I take something like Kohli and Dhoni, Dhoni, Kohli? Are these two different elements, or is it considered the same?
No, if so, you are saying that A is related to B. Okay.
I mean, yeah, correct. Yeah, form a relation where A comma B, where A and B belong to say same country.
So that means Kohli and Dhoni, they belongs to the same country, right?
Correct.
So Kohli and, so you can say that in my relation,
yeah,
Kohli is there, right? Because Kohli, they're basically the same element, right? So they come from the same country, right?
Correct.
Then Kohli Dhoni is also there, right?
Okay.
Dhoni Kohli is also there, right?
Okay.
Then Dhoni is also there, right? And you have maybe Hayden and Hayden, because there is no other element, other player which is from Australia. Okay, so then this will be your relation.
Okay, so it's not that just if I take Kohli and Dhoni, that covers everything. So I have to take all the Cartesian products.
This is your set, right? This
Right.
is your set. Okay.
Yeah.
So relation is basically it's a subset of A cross A.
Okay.
And you are defining your relation so that A is related to B if they are from same country, right? So according to your condition, you have to form all the possible pairs.
Okay, sir. Yeah, thank you. That's my question. Thanks for clarification.
Okay, so any other questions?
Sir, my name is Kamal. So will this session will be put down in the portal, sir?
Yes, not portal. It will be in YouTube.
Yeah. All right.
Okay, then I'll stop the session now.
Sir. So where will you provide that solution?
Sorry?
So where will you provide the solution of question practice assignment?
Yeah. Maybe I'll talk with Subham. Probably maybe tomorrow. Okay.
Sir, this is Dr.
Send discussion forum.
Excuse me, sir. Sir, I have a doubt. So can I ask now?
Like from activity or like some general doubts?
Activity question, sir.
Yeah.
So it's from activity 1.6 and question number 3.
Just a minute.
Here the options are the correct answers are option 2 and option number 4. Sorry, option number 3. I can't understand why option 3 is an answer.
Option 3 is not an answer, you are saying, right?
No, they have given option 2 and option 3 are correct answers.
Correct answer. Do you agree with option 2 and option 3?
I agree with option 2, but I don't understand how option 2 is an answer. Option 3 is an answer.
So option 3 basically says what?
Sorry, sir.
No, just a minute. Let me. Which of the following set of square the first 100 natural numbers? Okay, first 100 natural numbers. So what is option 3? Option 3, set up all natural number, right? N is n. And what is the next condition? Square root of n is also n, right? And n is less than 1000, right? So
yes, sir.
So do you think 1 is inside this set?
Sorry, sir, I can't understand.
Do you think 1 is inside this set?
No.
No, let her answer this question. Do you think 1 is inside this set?
1. No, sir.
Why?
Because square root of 1
is always positive. So we are for this course, square root of a positive number is always positive. Yeah. So square root of 1 is what? 1.
Okay.
Right? So
Yes.
1 is in n, square root of 1 is in n, and 1 is less than this, right? So 1 is an element of this. What about 2?
It's not a natural number.
Square root of 2 is not a natural number. What
Yes.
about 3?
It's not a natural number.
So if you can take 4, right?
Yes, sir.
So similarly, you can take 9 also, right? Similarly, you can take 16 also, and up to you can go up to 99 square, because you can't take 100, right? Because 100, sorry, you can't take 100 square, right? Because if you take 100 square, then this condition will not satisfy.
Okay, sir.
Yes,
Got
sir.
it?
Okay, sir. Yes.
Yeah.
Thank you, sir.
Yeah.
So last question, I have a doubt.
Which one?
Activity 1.11, question number 2, the maximum or the minimum one. So I have a doubt on this.
What is, yeah, so the product of maximum value of this function, 9 of modulus x minus 8.
Yes, sir. So how to find minimum value and the maximum value?
Yeah, just a minute. Let me. Product of minimum value of this function. Minimum value. And you have maximum value. Right? What is, can you tell me what will be the maximum value of this function?
So for this one.
Sorry?
It will be positive real, all real number.
Why this is always positive real number?
Because the mod is present here and the value of x plus 8 is always be positive.
If x is 10, what will be the value?
X is 10, then it is 1. X plus 2, 18 minus, yes, minus 7.
Yeah. So this part is always positive, right? This part.
Yes.
This part is always positive, right?
Okay.
So if you increase this part, okay, if you
Yes, sir.
increase this part, then the total value will decrease, right?
Yeah.
If you increase this part, then this total value will decrease, right? So
yes.
if the value of this thing is minimum, right, then the value of the total part will be maximum.
Yes.
So when this value of this part will be minimum?
When x equal to 8.
X equal to 0.
Yes.
Sorry, x not,
equal to 8.
Not x equal to 8.
Sir, x equal to minus 8.
Minus
8.
Yeah.
Okay.
Because if you take x equal to minus 8, then you will get 0, right? So that means the total value of the function will be 11. Okay. So this is the maximum.
Yes.
So now you need to find the minimum value, right?
Yes, sir.
So any idea how I can solve this question?
We need to make it 0 as per.
Why?
When we increasing the value of x, then it will be increases, and decreasing the value of x, it will decreases by the rule of this function.
So this part is always positive, right?
Yeah. Then the minimum value should be minus 8. Then we put 0 on this one.
Correct. If you put x equal to 0, then you will get minus 8. Correct.
So actually, I am solving this problem, but I'm multiplying the 0 and the -8. So
Okay.
I'm occurring 0, 0, 0 all the time.
Okay. Now you got it, right?
Yes, sir. Thank you.
Okay, thank you. Okay.
So this is a general question. So you said that the notes for the set theory formula are available in supplementary contents, but I cannot really point where.
Books.
In books. Okay. Thank you, sir.
Yeah. Okay.
Sir, can you please upload this note in the portal? Is it possible?
Which one? This one?
This, yeah.
Okay, I don't know. Do you think this will help you in any sense?
These are just solutions.
Okay. But again, like I understand these are the solution, but again, I have not. So I have written most of the solution vaguely. Okay, nothing is precise. Okay, if you want, I can upload it.
Thank you, sir.
Yeah.
So activity 1.1, sir. Question number 5.
Okay. Yeah. Question number 5. I have discussed. Okay. No. Sorry, I have not discussed.
The question discussed in the last class.
Yes, sir.
Yeah, probably. But again, like let me give you the hint. So see, Pth October and Qth October, right? Sital's birthday is on Pth October, and Karthik birthday is on Qth November. And one more thing is given, right? They are perfect square, right?
Squares. Yes, sir.
So that means P can be either 1 square, 2 square, 3 square, 4 square, maximum 5 square, right?
Yes, sir.
It can't be 6 square, right? Because 36, okay, you can't have a month with 36 days, okay?
Yeah, sir.
And similarly, Q have also possible choices, okay? So you try to, so now you have 5 options for P, and similarly you have 5 options for Q also, okay? Now you try to subtract Q and P in the sense by the date of the months to see for which values of P and Q it will give you 10. Okay.
Okay.
Because it's saying like Sital was born 10 days before Kartik. Okay. So you have to find a value of P in October. Okay. You have to find a value of Q in November, so that the difference between P and Q is 10.
Okay, sir.
So I had a question. It's not about a solution, but sir, you've already discussed it. In activity 1.6, question number 5, I know the way that you discussed it. So, but there's also another way where which was discussed in another activity session where they were using number lines to solve this question. So which one would you recommend for these kind of questions? The method that you used for solving the 5th question, or using number lines?
In some sense, actually, I have used the number line. Okay, but the only thing is I didn't draw the number line explicitly. Okay, so when you are so see, if you are doing it maybe for the first time, then it's better to draw the number line and then try to solve it.
Okay, thank you, sir.
Yeah.
So 1.3, question number 3.
It's integer, right? How many integers are
Yeah.
there? Yeah. So square root of 3 is not integer, right?
Yeah, it is not integer. 2.5 is also
not integer.
Not integer. E is also not integer.
What about square root of 49?
Yeah, it
Integer,
is integer, sir.
It's 7, right?
Okay, sir. That's it. Thank you, sir.
Yeah. Okay, I'll stop now. Okay.
Hello, sir. Sir, I was having a general query. Means whenever students ask a question, means can you just share your screen to that portal, because on my Android mobile I am not able to see that question. I mean, I can also get a glimpse about that. If even though I don't have that question, then also.
Yeah, that I agree. But sometimes what happen, okay, like I am not sure. Sometimes I have to do it separately. Okay, so I am not sure. Sometimes what I have to do, I have to share my portal. Okay, then I have to stop sharing it. Then I have to come back and I have to share my board. Okay, so if I do it again and again, then it will take a lot of times. Okay, that's why I don't prefer to share portal, and as well as then again I have to stop it, then again I have to come and share the board. I don't know if I can share both the things at a time. Okay, I have to check one.
One small help hint requires how to prove this onto function in a simply way. Like for a one-to-one function, we substitute value of x and it should be unique. So that is understood easily. So for onto, I'm not able to follow them. That's a simple way.
No, again, like as I said, see, there is no specific method that I can tell you that will work for all the functions. Okay, so if you try to solve more and more questions, then only you can get a better idea. Okay, I'll see. The thing is, only thing I can suggest, you try to solve all the questions. Okay, then only you will have enough idea so that you can implement in exam. Okay,
so only by practice we can.
Yeah.
Sir, would you mind if I agree to if I like to help him in making him understand personally?
No problem. Yeah.
So, and if at all he agrees also, of course.
Yeah,
I just
definitely.
make sure that he should know. That's it. No other reasons.
Yeah, you please go.
Yeah. You can ping me on the group this by the name R Drake, and we can connect on video like WhatsApp video, and I'll make sure that you understand whatever I can try to do that.
Okay.
Thank you. And sir, I have a problem, like I don't get this meeting ID and password. So how to get it? Like every time the meeting is there, I have to contact someone and then get it, and that too very difficulty.
Can you share this portal? Hello.
Yes, sir.
Can you share this? See this portal?
Yes, sir.
You have this course introduction, right?
Yes, sir.
So you have a calendar here, right?
Yes, sir. I have a calendar.
I
have added the calendar, sir.
You can get it in the calendar. I don't know. So you have to add the calendar. That's all. Okay. Once you add the calendar, then you can easily get it.
Anyway, sir. Okay. I don't get it. That's the reason I have asked you.
No. That is what it's there in the calendar. Maybe you try the setting of your calendar. Okay.
Okay.
You try to maximize the calendar. Okay. There is a maximize option. Don't see with this minimize option. Try to maximize it. Then maybe you have ignored that mathematics for data science part. Okay. You try to tick it. Okay. Then probably it will show. Okay. But it's there. Like, see, certainly it's there in the calendar. Okay. If there is any problem, then most likely it's the problem with the calendar setting.
Okay, sir. Thank you, sir.
Yeah.
Thank you. And when is our next class, if at all, in the meantime, you can let us know?
Next class, just a minute.
So that
I also don't, I have to check, just a minute.
Tomorrow open session.
Yeah, it's tomorrow.
Okay, tomorrow.
Is it for mathematics?
Yes.
Yes.
And okay, right. If anyone can share the meeting ID and password, I'll be very thankful to you. Although I'll try to look what sir has told me, but sometimes. Thank you.
Thank you so much, sir.
Thanks. Thank you.
Thank you, sir.
Thank you, sir.
Thank you.